We are now able to run our state logic, but of course we don't still have any. Before we go ahead and start adding some logic though, we first need to create our player input. The reason why is that we are using the new input system, so we'll need to create the player input ourselves. Thankfully it's quite simple to do that. Let's start by creating a folder in our assets folder, which I'll name input actions. Inside we'll create two new folders, one inside of the other. Characters, and then player. Inside the player folder, we'll create its input actions by right-clicking in the project window, going to create, and input actions at the very bottom. I'll name them player input actions. When you are done doing that, double-click on the asset file to open up the input actions window or press on the edit asset button. I'll dock the window right next to the game tab. Now, if you have never used a new input system, you likely have no idea what is what. While I won't do a deep dive into what each option does, I'll at least try to explain what we need to know for this tutorial. The first thing we want to create is what Unity calls an action map. This is nothing more than a group of inputs. You can divide your inputs in whatever way you desire, but we'll create a player action map that groups every player input. So let's go ahead and press on the plus icon, which has a new action map. I'll name it player. When we select an action map, Unity shows us the existing inputs known as actions of that action map at the right side. It should come with a default action already, but feel free to right click on it and press delete. Right now we'll only be needing two inputs. One is for our movement, which will be making it be our WASD keys. And the other one will be to toggle between our walk or run states, which will be bound to the left control key. To do that, press the plus icon and name the first one movement. Then press it again and name the second one walk toggle. Select the movement action again. At the right side, we now have a properties area for the currently selected action. This area allows us to choose a few things, such as the type of value that we want our input to return, what type of interaction is needed for the input to be called, and if we want to process that data, such as clump the returned value. For our movement input, we want it to be constantly reading for changes, so that we can get an updated value in our handle input method. The way we do that is by setting the action type to value. The value type is an action type that continuously tracks changes on that action. This is different from the button action type that only tracks changes whenever we press or unpress an input. Now we want our movement input to return something that we can use to move horizontally. If you have ever used the old input system, that would be the get axis or get axis raw of the horizontal and vertical axis, in which you will then set the vertical axis value to move on the Z axis, as X and Z are our player horizontal axis in 3D. So all we need here is a vector 2, as it holds the two values we need. We can choose that return value type in the control type dropdown. We now have the type of input and value we want to receive. However, we haven't really set any key to this action. To do that, we use bindings. When creating an action, Unity already has a default binding to it with no key attached. However, we want our movement input to be the WASD keys. Currently, our binding is just one key, so we can't do that. Thankfully, there are other binding types depending on the chosen action type. So go ahead and right-click in the current movement binding and delete it. Then press on the plus icon at the right side of the action and choose Add to the Vector Composite. I'll name it Keyboard. This now allows us to bind one key for each direction. To bind a key, we need to use the Path dropdown. This has quite a lot of keys to choose from, and you could go ahead and go to Keyboard and search for the key you want. However, we'll do something simpler and faster, and that's to listen for our own input. If we go ahead and press listen and then press W in our keyboard, an option saying W keyboard shall now appear. Go ahead and select that one. Our up direction is now bound to the W key. All we need now is to do the exact same thing for our other 3 directions, so go ahead and do just that. Just in case you didn't understand, binding a key to a direction here means that W, for example, will get the value of up, which is 1 in the Z axis, which of course in our vector 2 will be 1 in the Y variable. If we press, let's say, WD, then we'll get a value in the X and in the Y variables of the vector 2, and that value will already be normalized, as in our keyboard binding we have the digital normalize mode selected. That's it for our movement input, so let's now do our walk toggle. In Genshin, whenever we are walking or running, we can switch between both by pressing the Ctrl key. This input is reading like a button, waiting for us to press on it and nothing else. There is no reason for us to continuously track this input value, as we don't really need to use it anywhere else, besides when switching between these 2 states. Because of that, we'll choose the button action type. For our binding, we'll be listening for the left control key and choose it. We now have the necessary inputs to start moving, so all we need to do now is to save them and somehow read them. To save these input actions, simply press on the Save Asset button above. If you wanted every change you do to automatically save, then you would enable the autosave at the right. I will however not do that. We now have our inputs saved, but we still need a way to access them. If we select the Input Actions asset file, we can see in the inspector that we have an option to generate a C# class. This class is automatically generated by Unity and provides us a way to access these input actions we have just created, so feel free to enable it. Now, there are a few fields you can update, but we'll leave everything to their default values and instead just press Apply. This should create a new C# script in the same folder with the same name as our input actions asset file, as well as automatically generate code of our action maps and actions, including their bindings, properties, etc. That's great, but we of course still need an instance of this class to be able to use it. To do that, we'll create our own player input class. So go back to the player scripts folder. In here, create a new folder named Utilities, followed by Input. Inside, we'll create a new C# script to which I'll name Player Input. Open it up and start by removing the default methods. We'll leave the monobehavior inheritance as we'll need it later. We need a few things to start using our input actions. The first is of course an instance of our player input actions class. To do that, create a new public property of type player input actions, which I'll name input actions. I'll give it a private set. I'll also create a reference for our player action map so that we can access it right away. To do that, type in public player input actions, which is our generated C# class dot player actions. I'll name it player actions as our action map is named player. The dot player actions we've added is automatically generated by Unity and represents the struct type of our player action map. If you've named your action map something different, then it should be your action map name with actions attached to it at the end. With that done, we can start by creating a new instance of our input actions. We'll do that in the awake method. In here, simply type in input actions equals to new player input actions. Then set our player actions to be equal to input actions.player. Note that while player actions is the name of the action map struct type, player is the name of the variable of the struct type. We now have a reference for our inputs, but there is a mistake I see some people make quite often, which is trying to read their inputs now. While we indeed have an instance of our player actions, Unity requires us to first enable them. To do that, we'll use the monoBehavior onEnable method and also the onDisable method to disable them, as we don't want them to be enabled if the player GameObject is no longer enabled. So add in the onEnable method and inside type in inputActions.enable. Then add the onDisable method and call in inputActions.disable. We are now able to read our inputs. Of course, we still need to add this class as a component of the player, but we'll also need to add a reference to it in our player script, so that we can access it in our states. So go back to our player script. In here, start by creating a new public property of type playerInput. I'll name it input. Make sure you type the same property set as I do, but I'll most of the time make it private unless we need to be able to set the value from other classes. Then in the awake method we'll get its reference by typing in input equals getComponent of type playerInput. We can now add this playerInput class as a component of our player, but let's first add the requireComponent attribute. Above of our player class, type in requireComponent type of playerInput. Now every time we add a player component to a GameObject, it will automatically add the playerInput component with it as well. Save and go back to Unity and select the player GameObject. If Unity didn't add the playerInput as a component automatically, add a new component of its type yourself.